Hello, I am David D. Hilster, a critical thinker, dissident scientist, and if you are not science woke, then this is the place for you. No, I'm not talking about flat earthers, climate change deniers, or Trump. I'm talking about the Big Bang, relativity, plate tectonics, particle physics, anything fundamental to physics or cosmology. There are literally thousands and thousands of scientists from around the world that have been working for decades outside the mainstream, who have identified problems, fixed those problems, and who are proposing new theories and models. You won't find anything like this on YouTube, so you want to make sure you want to click down below on the subscribe button and the little bell next to it, and you'll be alerted to when our next video drops. Well, I had my first live Q&A session on Friday at 9:30, and it was a success. I want to thank everybody who attended. I'm going to do that weekly now because it went really well. I figured, it just go, I'd try it, no one show up, and people showed up. They enjoyed it, and we had a really great discussion where I took questions and took comments and commented on them live. It seemed to really, people liked that, and they said, hey, let's do it again. So every Friday, you'll get Dissident Dave at 9:30 Eastern Time in the U.S., and of course, I invite you all to participate. And if you didn't see it, you can look back and see it. It's recorded, of course, on my YouTube channel. Well, from my first one, I got Lisa, who is new to critical thinking, is new to being science woke. She's been woke in all kinds of other forms, but wants to be science woke. She says, Dave, I'm a beginner. I don't know where to start, so I am going to start, and we're going to start here, and that is the mainstream problems. Yeah, boo. There are problems with the mainstream, and you don't know about them because they don't talk about them, and a lot of them don't talk about them because they don't think about it. So I'm going to tell you about it. And these things in mainstream have big problems, not small problems, big problems. And you're going, wait a minute, all that? Yeah, the Big Bang, relativity, particle physics, quantum mechanics, plate tectonics. What else is there? Not much. And we're going to go through these one by one so you become science woke. And here we go. The Big Bang. Well, where did that come from? It comes from redshift. What's redshift? Well, when you have an ambulance go by or a police car go by, it goes, you hear that? That's a Doppler. That's the Doppler effect. We all know that. We hear that. Why? It's the changing of the tone because the frequency changes because the thing's moving and the sound waves moves. Before they're coming at us, the sound waves are crunched together. When they go apart, they're further apart. So we get a shift. Well, the same thing can happen if objects are moving at very high speeds in space. And so when we see a star, it's going to be this color, but it's going to be shifted to the red color a little bit if it's moving away. And of course, that's what they saw. Red shift everywhere. Well, is redshift is moving away the only explanation for redshift? No, it's not. And why do we care? Well, it does explain it, so what's the big deal? Well, let's look at a couple things. First of all, everything's expanding. We just happen to be in the center of the universe where everything expanded. If it did expand and exploded, why isn't there this big void like Cameron Rubasol said at our last Critical Thinkers Conference? Well, if we're in the middle, why is there this big void around us? Because if it explodes, it's all moving away. It's space. It's sort of empty. It goes out there. Well, the universe is expanding into what? Well, the universe was the size of a pea. What else is around it? Not universe? What is that? And then they say, well, space itself is expanding along with time. That's why we don't see it or feel it. Everything's Guys, there's only so far before you start using your critical thinking and saying this is baloney. Well, what came before the Big Bang? Well, I do have a video on that. If you look on right above there, I have a link to a video of what Stephen Hawking, God rest his soul, said about what's before the Big Bang. And when you see the video I made of it, you're going to think to yourself, this is cockamamie. This is no good. This is cosmic doo-doo. I just made that up. That's pretty funny. Okay, but what's the problem? The Big Bang, it's what caused it? Is there a big crunch? Will it go forever and then it's all done? Well, it turns out that we see life cycles of stars and planets and even galaxies. That doesn't sound like a Big Bang. So you're thinking, you've got all these problems, like what caused the Big Bang? What's before it? We don't know. Why do they call it the universe? Why does space hit all these things that are not making sense? And then, of course, we have this other problem. Every time we get a bigger universe and we look into a place in the sky that looks completely blank and void of anything, we get a better telescope. What do we see? hundreds, thousands, millions, billions of new galaxies that are way more mature than they should be because of the Big Bang and what happens. Oh, well, the universe is now older than it was because that just seems to be an endless cycle. So just with those things alone, you're starting to say to yourself, maybe the Big Bang is not a good idea. Maybe there's something else. Maybe redshift is caused by something else. And that's fact what critical thinkers say. Let's go to relativity. There are two types, special and general. Special talks about the speed of light limit. You can't go faster than the speed of light. You've heard that before. Mass increases as you get close to the speed of light. If you haven't heard about that and it doesn't make sense, good job, good job. That is, if it doesn't make sense to you, then you're a critical thinker because it doesn't make sense because they never tell you why it would increase. The mass increases. They just tell you it does. And what do I want to do? Well, I want to shoot myself in the head when I hear those kinds of things. Time dilation, time slows down, length contraction, and of course, there's a lot of evidence against this. In fact, go see my movie, EinsteinWrong.com. Go Einstein Wrong, go to EinsteinWrong.com, see my movie, it's $3. Or if you find one of my videos, I give you a secret code in it, like an Easter egg, and you can watch it. There are still some left to watch it for free. You're going to see in there all kinds of evidence against special relativity, and of course, including GPS, which they say supports it, but doesn't. And of course, the evidence that they do show for special relativity is suspect. And of course, when you have the Stanford linear accelerator guy from mainstream telling you, me on camera in the movie called Einstein Wrong, saying that he has to unteach special relativity, then you know something's not good with special relativity. How about general relativity? What's general relativity? That's the idea of space-time, fabric of space-time, that rubber sheet bends, whatever that is, and that causes gravity because then it bends it and then the moon gets sort of stuck in it, goes around and around. They always have that big rubber sheet and those, you roll the ball around it and it goes around. You go, oh, I get it. And then you start to think, we actually asked one in the Einstein exhibit in 2005, in the miracle year of Einstein. Dr. Karasani says, oh, what's the rubber sheet? The guy got so frustrated he went on break because they don't know. And it turns out then what we have against this? Well, it turns out that we have a NASA scientist, Dr. Edward Dowdy, who is a member of our group, who says that light bends, but it only burns in the corona of suns. What's the corona? It's the atmosphere. What's an atmosphere? It's got mass in it. It's got gas. It's got plasma. It's got free electrons, free protons there. And when it hits it, yeah, it can bend. But outside the corona, it doesn't bend. But Einstein says it should because it should bend a little bit because it's space-time and it goes out for almost infinity. So it doesn't bend where it's supposed to be. Evidence against. General relativity, problematic. Now we go to particle physics. Well, today and age, what do? They invent the particle, then they look for it. And that includes quarks, Higgs boson. Neutrino was another one that they invented and said they needed to have because it saved special relativity. So basically, that's the problem. They invent them and then go find them. It used to be we'd sort of find it. That's the way we found the positron and the electron. Positron and electron, we sort of found it and then said, what's that? But now, no, we invent them. And if we invent them, then we make giant machines, bash things together so much that eventually we'll find whatever we want. We can even find our name probably written by a particle if it flies off in the right way. They call those signals, and those signals, then they say, oh, we found it, therefore I found it, I get my Nobel Prize, please give me $2 million. Anyways, they have absurd attributes like color, strangeness, upness, isospin, a half a spin. What's that? Half of it spins? I forget it. And color, and they do say, oh, color. We have color, but there's no color. It's not color. It's color. You get it? No, you don't get it. Standard models have too many free variables. What are those? Fudge factors. They're fudge factors, so that they're symmetrical model that's not really a model, that's just conceptual, looks neat so they can put it in boxes and draw nice diagrams about it. But there's no physicality to the particles. You want to read the Higgs Fake? Great book. Look, really thin, and I will randomly open a page. No equations. No equations for those people who are new. and who want to read about particle physics and the problems it has, there's other ones, Bankrupting Physics. Look up Alexander Unsker's super great books, and he is a doctor. He is a particle physicist from Germany, like Einstein. So there. And of course, he says throw everything out from 1930 on. I probably think even before that, but that's okay. I agree with him. And let's take a look at, just to give you an idea of, let's look up one of the subatomic particles and show you the physicality of it. It's a big circle. A proton is a big circle, and it's inside it it's made up of 3 quarks. And of course, quarks should be one thing, but they're like ups and down quarks. So it's made up of 2 up quarks and 1 down quark, and the gluons that mediate the forces binding them together, those are squiggly lines. The color assignment of these individual quarks is arbitrary. Are you seeing any red flags, critical thinkers? Are you seeing are the students who want to become science woke seeing any red flags here? Yeah, but all 3 colors must be present. So they're arbitrary, but they must be present. What does that mean? It's like, this sounds like a meeting with your teacher, the teacher of one of your kids. They must be present. All the parents must be. And then if that's a proton and it's round and it's, I guess, maybe a sphere, but no, it's just round. If it's made up of the quarks, well, those are round. Well, it's not round then. The proton is like, they're just pictures. That's the thing. That's what I'm saying. There's no physicality. They're just squiggles and pictures and colors and symbols. Going on, quantum mechanics. This is the worst. Quantum mechanics is the worst of the worst of the worstest. They talk. Quantum mechanics has to deal with subatomic particles and photons, and subatomic particles and the photon without models. That's what the problem is in quantum mechanics. They don't have models for this stuff. They don't have a model for what gravity is. They have no model, no physicality for any of this stuff. Particles of light's a photon. It's a particle. Einstein said that. Oh wait, but it's a wave because it acts like waves. They have this double slit experiment where they can't, and you can't find real ones. I just realized that for this talk I couldn't find a picture or a video of someone really doing this. That's a suspect in itself, which is really weird. So we're talking about an experiment which you can't even see. They're all diagrams in 2 dimensions or 3-dimensional diagrams that tell you what it's doing. Doesn't that tell you something? Why don't they show it to us? I'm not saying that it doesn't happen. I'm just saying that's weird in itself. I just found that out today. And they have the delayed choice quantum erase experiments. Look it up. You will not believe it. Look it up on the Wikipedia, and it basically says if you look at, I'm not kidding, if I look at a photon, and it was 3 billion years ago, going around a sun way 3 billion light years away, and I looked at it with binoculars, it would go on one side. If I looked at it with my bare eyes, it would go on another side, and that is why they call it the delayed choice quantum eraser experiment. Guys, it is so far from science. This is voodoo. This is absolutely voodoo. Well, let's keep moving on. Here we go. I just wanted to show you what the double slit experiments. This is where quantum mechanics goes wrong. This is the experiment they all talk about. This is the one you can't find any real diagrams on it. Maybe like an interference pattern you'll see, but you won't see the whole setup or anything. On the left-hand side, you have, again, what you have right there is the slits. So you have on the left-hand side 2 slits, on the right-hand side 2 slits, and then you have a light source at the bottom coming up here. Well, on the left-hand side, the 2 slits result into 2 blocks on the wall. That's the right here. Right here is the wall, and of course on the left-hand side you see the 2 slits. You can see them on the wall from the light going through it. On the other one you'll see an interference pattern because light is a wave, and you have the 2 waves that if the light is a wave that goes through there, those 2 waves interfere and they create the interference pattern on the wall. And of course this is where it all comes from. You can look at, I'm not going to get into the details. I'm going to get into that someday. You want to look at my dad. He explains some of this particle youtube.guru or youtube.particle.guru. And let's go on with plate tectonics. They have crazy motions of the plates. That is, the plates, because they say that the Earth is a fixed radius and has not been expanding, that when you fit Africa and South America together, you can see that, oh yeah, they fit together, and that creates this idea of Pangea. And this is Neal Adams has a great video. I'll show you that. And that there's just mountains of evidence that the Earth has been expanding. Why? Because Africa and South America fit together. It turns out that everything fits together on the Pacific side too. It's just that the Earth's been expanding. It's expanded more on the Pacific side. But when you take away the seafloor bed, like this beautiful model from one of the expansion tectonics, you see these colors there. There's Australia, but I'll get you over to, here we go, Africa and in their South America, if you can see there, and those stripes in the middle. If you take all those things with the stripes away, including in the Pacific, you can see the stripes are bigger because they've expanded faster, that the entire thing comes together. And I will show you that in a video. I'm going to show you in a video. It's called it's by Neal Adams. Look up Neal Adams and Expanding Earth. And this one is Pangea. He's going to say, Pangea theory proven wrong. So I'm going to play it. I'm not going to have it narrated, but basically you're going to see Pangea's solution. Everything comes together on one side. That makes the Earth lopsided. Why would all the land come on one side? That makes no sense. As Neal Adams says, it's a knee-jerk reaction from the idea that any child can see that Africa and America and all these things fit together. But they also fit together on the other side. So if I let this go further, I'm just going to move ahead here. We'll move it to just when he starts to show the expanding Earth. There it is. The Pacific and the Atlantic come together, and you notice that as you take the seafloor bed away, the Earth gets smaller, but Australia fits together, snugs up right with the Soviet Union and the United States, and you can see that it sticks to Antarctica for a while, but it all fits together. And again, we don't look at that because we have mainstream science telling us every day that the Earth, that would require mass increase. That would require an expanding Earth. That's too radical for us. But all the data is absolutely 99% of the data out there that has been collected by expansion tectonics show that the Earth has been expanding. And other bodies in the universe too have been expanding. Let's go to the mainstream versus dissident finally, and we're going to take a look at all the things we talked about that were wrong and say, well, okay, Dave, it's easy to say that they're wrong, but what's right? And that's one of the great things about this channel. A lot of my subscribers love about this channel. We don't just criticize, and we don't give we do give great arguments about how things are wrong, which I try to do for you now, but we also have better alternatives. Well, the Big Bang, instead of the Big Bang and this whole idea of, well, it's just an eternal infinite universe, and the life cycles we see, and every time we get a telescope to see further and we see more and more and more, it's just the same in a lot of directions. Oh yeah, there's the birth and death of planets, stars, and galaxies all around us, but it's not a Big Bang. The redshift is actually explainable by what we call tired light. That light, the nature of light, it cannot go infinitely along in space at the speed of c, and the frequency stay exactly the same. It's going to encounter things along the way because space is full of stuff all over. Yes, there's a lot of emptiness, but there's a lot of stuff in there. Okay, relativity, we just say, goodbye, relativity. We don't need you. Our new models don't even care about it. It doesn't even matter. This whole thing about, being in an elevator or being on a train and then turn the light on and do I measure it the same? In fact, GPS satellites actually take the speed of light, add the speed of satellite to it, which is faster than the speed of light, which you can't do. But then on the way back, then they subtract it and they say, oh, we didn't violate anything because we added it to it, which violates it, and then we subtracted from it, which violates it, but it averages out to C, which somehow doesn't violate it. Come on. Particle physics, we really do need to start over. 1930, quarks gone, Higgs boson, throw them out. You guys using your Higgs boson microscopes and propellants? Nope, they're not there. They serve for nothing. Quarks never produced anything useful. Quantum mechanics, we have newer models to describe the same data, and we don't need to have all this crazy idea of quantum eraser history, foamy whatevers. It doesn't matter. Spooky action out of distance. None of this. Don't need it. We can use simple Newtonian physics to explain all this stuff, because we have our models for gravity, for light, for even magnetic fields are all Newtonian and physical, and particles and things you can actually hold upon and say what they are. And of course, plate tectonics, expansion tectonics is way, there's mountains of evidence. Even some of the people in our group who are actually geologists have admitted to me, he said, Dave, I'm not expansion tectonics because I make a living at geology, but he says, I have to admit there's a mountain of evidence for it. So going forward, we do have new areas in our critical thinkers and our dissident scientists and our science woke people, and they include infinity, something that they don't talk about in regular mainstream science, philosophy, which they used to talk about, which they don't anymore. We talk a lot about that. Natural philosophy is the rules of nature. Structures, the structures of way things, just structures work. What structures, why do hexagons work well? Why do we see spheres and hexagons or things that look like those things? And why do they work so well? Why do we see those things in nature? And then, of course, we have new theories and models that describe stuff with physicality, which the mainstream doesn't do, and it describes lots of things that mainstream cannot. And I mean a lot. So, finally, why mainstream doesn't see problems? Well, the reason is the problems are too fundamental or too foundational. It's just, that's not the way they work. They say as we go on and we find equals mc squared, that's written in stone, it will never be thrown away. We find the secrets as if the nature has mathematics. We use mathematics in this decimal system. We came up with calculus and all those things, but it doesn't mean that even our math systems have the problems, believe it or not. Square root of -1 is a really bad problem in the rational number system, and we actually have things like the veritable number system. I've got a book right over here by Peter Erickson that says that we have better number systems even. Require wholesale changes. I mean, that's what we see in politics. We can't just tweak something anymore. We see we have to have wholesale changes in all of these things we've talked about, all these staples of standard and the standard model. And the mainstream deflects criticisms as we not understanding. Oh, you small children who don't understand these complex things. Well, the problem is that the foundations are often impossible to understand because they are illogical or paradoxical. That's right. It's not because they're hard to understand, Mr. Smarty Pants from MIT, Caltech, Oxford, the German Institutes of Physics. It's not because you're smarter. It's because your theories are impossible to understand because they're paradoxical. They are illogical. And they pretend, you pretend then to understand them, and you're in the club, and we are not. The foundation is vacuous. That is, the standard model is no model at all. It's just math. It's bad math. It's arbitrary attributes on arbitrary packages, as Alexander Unserker says. And then, of course, we also know that, in fact, that we have a long, long way to go. Remember, I'm Dave D. Hilster. Stay critical, stay thinking. I am your physics and cosmology and science therapist. Ciao for now.